Howdy and welcome back. So we're going to talk about, or I guess introduce some of the limitations of using the stack exclusively in our programs through this function problematic. So my first question to you is, what's problematic about problematic here? Let's go ahead and just look at it. We see, okay, problematic takes an integer called size, and then it's allocating memory for an array on the stack based on that size. Well, that could be problematic. We have to know the array's size at compile time. And if I trace through this, it definitely looks like we're getting it at runtime. Okay, so there's something wrong. And then we're returning in the address of that array. But this is on the stack. So what are the implications of that? Let's go ahead and look at the variable length array problem first and just go, okay, we've booted up our program. We've made the function called it problematic with size, which we got at runtime. We're now in problematic, and okay, it's very clear that this is not allowed because it's a variable length array on the stack, and the activation record, which means the activation record for problematic will vary within its size from each instance of this function, as well as the actual offsets to the various variables contained within that record will vary depending on the size of this array. So let's say we go ahead and, okay, we correct that. We go ahead and take away problematic's parameter. We go ahead and create a constant integer named size, and it's going to be thrown on the stack each time this function's invoked. It's assigned the magic number, which we should avoid, but just for an example, 3, and then A. So I guess we changed the name from data to A, but okay. A is going to be an array within this function. It's going to have 3 integer elements. Okay, that looks good because on every instance of this function, each time it is called, A is always going to be the same size. It will always be an integer followed by 3 contiguous integer objects comprising the array A. Boom, boom, boom. And then we get into why this is still problematic here, because we're returning the address to A, which resides on the stack. Okay, so we've booted up our program. We're now in problematic. And we're going through, maybe we're at the do something point, cool. Now we're going to return a pointer to the base address of our array. But let's go ahead and look at this a little closer. Where's the activation record for problematic? Pick a different color. This is the activation record for problematic. And we're going to return the address to the base element in that array, and we'll use it to initialize my data. Do you see the problem with this? Well, when this function returns, and when we're returning data, we're not returning the array. We're returning the address to the base element of the array. But that array lives on the stack. And when we've returned from that function, the activation record is removed from the stack, which means my data is now pointing to an object that no longer exists. So let's go ahead and talk about some of the limitations that we've observed through this example on the stack. Then in a later lesson, we'll introduce the free store, which will address these limitations.